Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they are working on. And today we have Harpreet. So, hi.
Yo, Alexi, what's going on, man?
Yeah. So, what do you want to show us?
So today I'm going to talk about SuperGradients, and it's an open source PyTorch-based training library. So let's go ahead and jump into it. I got a quick presentation, and I've pulled up create a little Jupyter notebook where we can kind of see it in action,
Mhm.
and also maybe give
And,
you guys a quick lesson on transfer learning in the
and
process. You ready?
maybe you can also say a few words about yourself for those who don't know you.
Oh yeah,
I
yeah, okay,
assume most
yeah.
people do know you, but in case, we
Yeah.
have somebody who doesn't
Duh.
know you.
I'm surprised that nobody knows me. I can't believe it. No, name is Harpreet Sahota. You guys might recognize me. I'm DevRel at Desi AI, kind of like the community manager of Deep Learning Daily back there. But I've also got a podcast myself, The Artist of Data Science, and fairly active on LinkedIn and other places. So yeah, that's a little bit about me. Started in DevRel just about a year ago after being a data scientist for a few years, and before that, biostatistician and actuary. Fell in love with deep learning just about a year ago, and I've been exploring it ever since. And so that's what kind of
Cool.
led me to Desi.
Mhm. Okay,
So
let's see what you
ready to
have.
roll?
Yep.
Yeah, cool, man. So real quick, I'll just talk about SuperGradients, our open source training library, and then we'll get into just a quick example showing you how to use it. So what is SuperGradients? So like I mentioned, it is a open source PyTorch-based training library for training deep neural networks. At the moment, it's primarily focused on computer vision tasks, but we are adding support for NLP in the near future. So SuperGradients, this library gives you the ability to easily access and fine tune production ready state of the art models for virtually any computer vision task. And that's whether it's image classification, object detection, or segmentation. You've got one single library that will help you perform all those tasks. So why use SuperGradients and not some other training library or maybe just your own code? Well, simple answer is that using a training library gives you a stronger starting point. But the challenge is that there's so many training libraries out there. There's TIM, Ultralytics, Detectron, FastAI, Hugging Face, and that's just to name a few. If you've tried them, then you know how difficult it can be to get started. All those companies, all those packages, they're all great. They've got wonderful tutorials, but you have to context switch between all the different tasks, right? TIM for image classification, Ultralytics for object detection, Detectron too if you're brave enough to use that. You've got to learn all of these different APIs and interfaces. And that could be challenging. Sometimes some of these libraries will have, hard-coded numbers in there. There might be some challenging integrations, so on and so forth. And again, like I mentioned, you have to learn a different library for the task you're trying to accomplish. But things are different with SuperGradients. In SuperGradients, we have an all-in-one training library right now focused on computer vision tasks. You can train any computer vision model with SuperGradients, and it's just one repo. And you can do that either from scratch, or you can use a pre-trained model for one of the main computer vision tasks. Again, classification, detection, segmentation. So helps you save your time, because now you don't have to search for the right model in various places or papers. That overhead of integration and implementation is also abstracted away. So it leaves you with more time to focus on your problem and training your model. Um, it also saves you time using classes, functions, and methods that have already been tested and used by many others. So you can use the training recipes that we over at Desi have built so that you can easily reproduce our reported results on your machine and save time for hyperparameter search while getting really, really good scores. Um, and last but not least, all the models are tested and validated for compilation into production environments and frameworks. And you've got documentation, code examples, notebooks, users guides that'll show you how to do all that. So I don't think there's any other repo out there that really takes production readiness into consideration. So just a quick history on why the team at Desi built SuperGradients training library. So at Desi, we have something called Desi Nets that we have. They're kind of our proprietary models. And so the team of researchers here tried a lot of the existing tools and frameworks, and they were able to find, a lot of features in specific domains, but they're all kind of disjointed. So they started compiling all these different features and training tricks into one library, and they started using that for internal use to train their DESI nets. And it really streamlined that training process. And so they decided to just open source this training library. And the result of that is SuperGradients. And let's dig a little bit more into SuperGradients. First, I want to start off with the model zoo. So this will show you the current pre-trained models that we have available. So first, we're looking at classification here. So these are all the pre-trained classification models that we have available to you in SuperGradients. You can see here, it'll tell you the data set it was trained on, the resolution, top 1, top 5, accuracy, as well as the latency on various different hardware devices as well. We also got these models right here for object detection that are pre-trained and available for you to use, as well as semantic segmentation models. So this is great because now everything is in one training library, and since everything's in one training library, you've got one interface to kind of work with. You don't have to learn a bunch of different
A quick question.
and
So
yeah,
I don't know much about computer vision, so I know what image classification is. But what is object detection and semantic segmentation? I'm not so sure. Maybe you can say a few words what these things are.
Yeah, so computer vision really has 4 basic tasks, right? So first is image classification, right? And you're familiar with this. The main learning task here is to find a label from a label set and assign that to the input image. And then we have the next step up from that. It's kind of like a natural extension. That's called object detection. So what this does, it identifies the location of one or more objects in an image, and it draws like a box around them. So the goal becomes
all these images with bounding boxes on top of that. That's object detection, right? There is this famous picture of I think from Beatles, like when they are crossing the like a road, and then there is like a bounding box on top of each of the. So that's object detection, right?
Yeah, object detection. So it's like a 2-step goal there. You're trying to localize, which is drawing the bounding box, and then once you've localized the thing of interest, you then classify that. And then there's semantic segmentation, and there's really 2 kind of flavors of, well, there's segmentation, 2 flavors of segmentation, semantic and instance segmentation. So in semantic segmentation, like the goal that you're trying to do is assign a label to each pixel in the image. So you're trying to segment and detect specific categories, and then finally label the boundaries between these categories.
So you have a mask, right? So you have a car, and then every pixel of this car, you say this is a car, and then you have a mask, and then you can maybe take out this car and then leave the background.
Yeah, exactly. So every pixel in the image would belong to a particular class, as opposed to object detection, where the bounding boxes can overlap between objects. Here you're trying to finally find the boundaries between the objects. And then instant segmentation, it takes semantic segmentation just a step further. And it, for example, like if there's 2 of us in a picture in semantic segmentation and we're standing right next to each other, semantic segmentation would like mask us as both the same color and say we're people. Instant segmentation would take that one step further and say, okay, here's one person and here's a different person. So it finds labels for individual instances in the same type of object. So it's kind of like performing object detection and semantic segmentation at like the exact same time. But it does so in a way that deals with multiple overlapping objects and like complex backgrounds. So yeah, those are the main learning tasks in computer vision. And so we're able to do all of that in one training library. And I think you can still see my screen here, but so all these models that we have, they've been validated for production readiness and benchmarked on some common inference hardware, GPU, CPU, and some edge devices as well. A lot of these models that we have, the pre-trained checkpoints, have really, really good performance compared with other repos and papers, and we're always continuously updating and improving them. So let's talk about how you can train your model in SuperGradients. So there's 3 ways you can train your model in SuperGradients. So once you've cloned the repo or installed the library, you can then integrate data and define the loss function that you want. And then you can choose between 2 options. You can load a pre-trained model or define your neural network architecture. Then you can build the model. So you can initialize our SuperGradient model object. And then now all you have to do is define the training metrics that you want and the training parameters. Then you go and just execute training. So if you choose a pre-trained model, it'll start from the trained weights and you can fine tune for your needs. And then the simpler one is just run the training recipe script on one of our state-of-the-art architectures, and it'll load everything for you and train on your machine. So let's see SuperGradients in action with some hands-on transfer learning. So I'll switch away from this screen here and I'll pull up this notebook. It's a freshly trained model here in this notebook, and we'll jump into it. All right, so let's go ahead and see SuperGradients in action. We are going to see SuperGradients with the efficient net model, and we're going to work on a task where we're trying to classify the car brands of different cars. So let's go ahead and take a look at what we got here. So first thing is install the SuperGradients dependencies. We're going to be using SuperGradients version 3.00. We'll import everything that we need for the example notebook that we have here. I've created a configuration class here that just kind of houses the different variables that we'll need for training. Also defining here some helper functions to download our data. So this will download data from my GitHub repo where I have the dataset housed. Then what we're going to do is create the image folders. So SuperGradients is compatible with PyTorch data loaders. So that's what I'm creating here. Creating a PyTorch data loader. Well, it will be soon here. First, just downloading the data. You can see here, downloading the data. The data itself, when I first pulled it, was not in image folder format, so that's what this does. This moves my data into image folder format. If you're not familiar with the image folder format, it's like this. We have train, and then all the different classes, and then we have the validation set, and then all the different classes in their own folders. So we'll learn a little bit more about this data set in just a second. So we have the car brands data set. It's images of cars for the 50 most popular car brands in the USA. I've included a link here where you can learn more. This is actually just coming from a Kaggle data set that I found. I'm into cars, so I always like to find car stuff. And we created the image folder format. That's all what's happening here. It's not really SuperGradient stuff. So the first thing we do here for SuperGradients is initialize our trainer. So our trainer is in charge of pretty much everything from training, evaluation, saving checkpoints, plotting, so on and so forth. The experiment name is the most important argument of the trainer, because every checkpoint log TensorBoard is going to be saved in a directory with that same name. So the directory will look like this: experiment name, and it'll have all the different checkpoints, so on and so forth. So we instantiate our trainer. Again, SuperGradients is compatible with PyTorch data loaders, so you can use whatever data loaders that you have, and that's what I've done here. I'm using a PyTorch data loader and just creating our data loaders. So I'm talking about image augmentations here next. So we're always adding more and more support. Soon in an upcoming version of SuperGradients, you'll just be able to pass as string arguments the augmentations that you want to perform, and you don't have to manually define on all the augmentations. So that's that's on the roadmap for us as well. We're always trying to improve this, but all I'm doing here is just performing some image augmentation as part of the data loader kind of pipeline here. Instantiate our training and validation data loaders. And we can see the images that we have. So these images are the augmented images that we have. I found it funny that the data set had actual people in there. And so you can see what the images look like. So this is kind of like a hard task in the sense that cars kind of look all the same, right? So I'm not sure how this model will be able to discern between the two, but I guess we'll have to wait and see. And so here we can see the validation set itself. This is just showing us a few different classes here. SuperGradients, again, it includes implementations of a lot of different architectures for classification tasks. One of them is EfficientNet. So link here to the EfficientNet paper, and you can find the architecture itself, the implementation. We have it in SuperGradients, and it's all right here, so you can see exactly how it is that we've implemented this. This has all been abstracted away from you, and you just call it with one line of code. And that's what's happening here. We're instantiating our model. And we can also examine, just using a PyTorch summary, just the model architecture itself. So you can kind of take a look and look at the different layers and blocks in the network itself. And now we're going to do some training. So SuperGradients, like the nice thing about SuperGradients is you'll notice here in the trainer, we passed an argument here called number of classes equals num classes. In our case, num classes is 2. So ImageNet itself is trained on 1,000 classes. So when we have our pre-trained model checkpoint, that means the classification head has, it's for 1,000 different classes. But we just pass here the number of classes that we want, and behind the scenes, SuperGradients will automatically replace the classification head to an appropriate one for you. So that's what's going on here. And on top of that, we've got a bunch of different training parameters that you can use for your training recipe here. So a lot of this stuff is just kind of implemented right out of the box for you in SuperGradients. So I encourage you to check all this stuff out. I'm not going to go into too much detail here, but just know that it's nice to have that all of these different features have already been implemented for you. But we can override these features. So for example here, instead of training for 300 epochs, we trained this model for 100 epochs. I changed the metric that we're going to watch to top 5. Just because the nature of the data set that we're working with. We got 50 classes. As long as the class that the model is predicting, as long as like the actual ground truth label is one of the top 5 predicted by the model, then I'm going to count that as a win and count that as a correct classification. Here I'll for right now I'll remove the exponential moving average for right now. And then I'll also remove checkpoint averaging. So right out of the box, SuperGradients will do exponential moving average for you, and also will do checkpoint averaging for you. But just to kind of show you the progression in model itself.
Is it important to know what this is? Is it important to know what these things are to understand the demo?
Not to understand the demo. I think if you're interested in exponential moving average and checkpoint averaging, I've got an upcoming blog post that'll detail those in detail, but you can always check those out. And so what we could talk about is accuracy top 5 and label smoothing cross entropy. So accuracy right now is just everyone knows that as top 1 accuracy, and that's a metric that tells you correct predictions to the total number of items. Top 5 accuracy is the one that we're going to use. It means that one of the model's top 5 highest probability predictions matches the ground truth, and if it does, we can count that as a correct prediction. So that's the metric that I'm going to be using for training. Then we've got label smoothing cross entropy loss. So this is the name of the loss function that we're going to be using for training. So you can always use your own loss function if you want, and we have a suite of loss functions that you could choose from. But the approach here is, we're dealing with multi-class classification, and cross entropy loss is just the default way to optimize a neural network. But label smoothing cross entropy loss offers an additional feature there, which is called label smoothing, and that just helps improve the model's performance. We'll talk about this a little bit later as we progress along the notebook. So the first thing I did here was train a baseline. So every those few features that we talked about have been disabled, and then we can look at the training that's happening. Just a note here, I ran this notebook a while ago, and I'm hoping that by the time we get to the end of this notebook that all the models will actually be trained. But this is, I'm training each one of these models for 100 epochs each. And you get a summary at the end of each individual training run as to how the model has performed. So you can see up until now, top 5 accuracy has been 0.75, 75%. Then we're going to switch on label smoothing cross entropy. So again, sometimes in classification problems, what happens is that the model is going to learn to predict a training example really confidently. This is not good for generalization. So we get a huge gap between our training and validation loss. So I'll have a link to this notebook. I'll give Alexi here a link to this notebook, and you can explore this for yourself. But there's a huge gap in between our training and validation losses. So as Andre Karpathy, he says in his blog post, Recipe for Training Neural Network, there's 2 stages to finding a good model. 1 is get a model large enough that it can overfit, so focus on the training loss. And 2 is regularize the model appropriately. So you give up some training loss so that you can improve the validation loss. So results we see here indicate that the model has successfully overfitted and is making overconfident predictions. So now we need to apply regularization. So that's what label smoothing does. It's a regularization technique for classification problems, and it prevents the model from predicting training examples too confidently. So all we have to do is pass this parameter in to the training params, the SuperGradients, and it automatically enables that for us. And you see the results here. We're doing a lot better here. Next, we're doing checkpoint averaging. We're going to enable that, and that's super easy to do here. We just pass this parameter here, average best model equals to true. So checkpoint averaging is another nice free trick that you get to help boost your model performance, and you get that right out of the bag. So it's again a post-training method that takes the best model weights and then averages them into a single best model. It's not exactly the same as having n models and averaging the predictions, because you have to run inference on n models and then take that average, but this just helps squeeze out a little extra accuracy. And so right out the box, you get this with SuperGradients. Typically, you'd have to code this up yourself. And here, our network is training. I thought it would get us here. Andre, my bad. I thought it would get us here quicker. But we still have 12 epochs to run. So it'll take a little bit of time here. I don't know if we should pause. I thought this would be done by now, dude. My bad.
That's fine.
So yeah. So
you can keep talking.
Yeah. So that's kind of the added benefit of SuperGradients. So while this is training for another 10 epochs, it should not be too fast. I'll go ahead and pull up the SuperGradients GitHub for you. Just got a few more epochs left here. So you can check out SuperGradients here. So we open sourced this at the beginning of the year. We've gotten so far to 555 stars. So if you think this is a cool library, by all means, go and give this a star. And we've got friendly user guide, docs, getting started page for you as well. And you can always take a look at some of the plug and play scripts that we have here. So right now we're using a Jupyter notebook with a lot of explanatory text and everything, but if you wanted to run it just as if it was a script, it would just be one line of code and super easy to do. You can see here that we've got a couple of integrations. We've got integrations with ClearML as well as weights and biases. And the roadmap, we've got a number of cool things happening on the roadmap. Specifically, we're going to be implementing paddle YOLO E, and we're rolling out quantization aware training as well. So some of the advanced features that we have here, knowledge distillation. So this is an interesting feature. I'm going to be presenting on this like a session early in 2023, and it's a super cool feature that's just kind of available to you right out of the box. We also have a number of training recipes for you to use. So here's the documentation for how to use our training recipes. What is a recipe? So to train a model, you need to configure 4 main components. That's the dataset, architecture, training hyperparameters, and checkpoints. We've got the recipes kind of ready for you right out the box. So it's almost like You can either bake a cake from scratch, or you can take one of those Betty Crocker boxes, just add milk, mix it up, and then put it into the oven. That's kind of what we're doing here with our training recipes, is giving you that that feature of just kind of training right out the box. So
while
definitely check all these out.
Yeah. So while it's training, so I wanted to ask you if you have any advice for anyone who is watching this.
Advice with respect to
life advice, data science advice, deep learning advice, any kind of advice.
Yeah. So I mean, life advice, man. Like, I turn 40 next year, believe it or not. Like, I'm getting kind of old. I didn't break into tech until I was well into my mid 30s, and I felt like it was just a thing that was not for me. Like, it was going to be impossible for me to break into tech. There's so much to learn. I've got a wife, I got 2 kids, and I just don't have time. But kind of shattered that misconception. Not only have I broken into tech, I think I've kind of climbed the ranks fairly quickly, and I think it just goes to show that just finding time is important. You have to make time, right? Time isn't just kind of like given to you for free. You've got to make time and make it happen. So that's that. With respect to deep learning, like, I was afraid of this stuff, man. Like, I thought deep learning was like the scariest thing ever. And I've got a master's in math and stats, right? I come from a quite an academic statistics background, and I was still scared of deep learning. But I knew that if I pursued my interest in deep learning, that it would open up a whole new world for me and whole new opportunities. So I just decided to double down and focus on deep learning. It's something that I was scared of, but I pursued it anyways. And I think the biggest advice I can give someone is, pick up a book like Grokking Deep Learning and try to, approach deep learning from a coding perspective rather than the math perspective first. If you approach it from the coding perspective, I think you'll develop a better intuition for it. The math is always going to be there. I'm not saying that you don't need the math, but I wouldn't start out with just learning all the math first. I'd figure out how it works and kind of implement it from code perspective first. That being said, our model has now trained. So let's go.
Thanks for the advice.
Yeah, no worries. So let's here see. You can see the top 5 accuracy that we've got here, 80% accuracy. So let's see how it actually does. So I've prepared a little function here that's just going to randomly choose some images. In this case, we got 10 images, and let's see how the model predicts. So predicted Jeep right, predicted Bugatti right, and it's just like from the back of the Bugatti with pretty decent probability too. GMC, you can see it predicted that right, as well as a Fiat. So that's pretty. I mean, I'm kind of impressed by this. That's Jennifer Hudson, I suppose. And
it actually got it right. Okay.
It got it right. Yeah. I mean, this is like, I think, I thought this was cool. Like, I was not expecting, when I first pulled up this data set and just kind of let the model rip on its own, I was getting like 3% accuracy. And then with a few minor tweaks along the way that you saw, was able to build up the accuracy more and more. And I was just surprised that it was able to get, granted the accuracy, like the probability is not the highest on some of these, but it's able to predict quite well. So let's go ahead and look at some other pictures here. Fun fact, Acura NSX, like the original NSX is like one of my dream cars. I've always wanted that, so that's why I chose this. But it, classified this as a Pontiac. I'm not sure why. The Porsche, it got right with some pretty high confidence. I got the Tesla Cybertruck right. Pretty low confidence there. Another Tesla. I also like Teslas. I do not have one. And here's a picture of me with my Porsche. Like I mentioned, SuperGradients is production ready. So all the models here can be compiled into Onyx. You just download the Onyx file and it's ready to deploy. And that is it, my friends. That's SuperGradients in a nutshell. So thank you so much. And for bearing with me as well. Hopefully the life advice was useful, and
it was.
And hopefully you liked SuperGradients as well.
Yeah, thanks a lot. Great demo. Please give them a star.
Yeah, and I'll be sure to share a link. And just heads up, like throughout 2023, I'll be doing a series of like sessions where I take a research paper that we have implemented in SuperGradients. I'll distill down the research paper to I'll abstract away all the math and try to give the intuition for it, and then we'll show how it's implemented in SuperGradients. So if you're interested in computer vision, want to learn more, or just interested in research papers, definitely join me on those sessions. I've done a few of them so far, and I've got a lot of great feedback on them. So I just want to make this stuff accessible as possible for people. So hopefully you'll join in on those.
Then, yeah, thanks.